Hi, I'm Kashish, and now I'm going to discuss EL6303 question 2 for fall 2015. So, our question is that we have to collect definitions of properties of stochastic processes. So, I started with the fourth part, which is the strict sense stationary process. So, consider the diagram that I've drawn here. Let this be time t1, t2 up till tn, and let this be t1 plus some constant c, t2 plus the same constant c up till tn plus c. Now this t1, t2 up till tn will define a set of random variables x1, x2 up till xn, and this shifted version of t1, t2 will define another set of random variables x1 dash x up till xn dash. So basically what the property of strict sense stationary process says is that the PDF, that is the density function of these two random variables, set 1 and set 2, should be the same. So fx1 up till xn, x1, x2, xn up till t1, t2, tn should be equal to fx dash, which is x1 dash up till xn dash, into x1, x2, xn up till t1. Oh, this should be t1 plus c up till tn plus c, t2 plus c. So these two are equal for any value or for all values of n and c. We know that the process is strict sense stationary. So considering the first order for strict sense stationary, so it will basically be fx of x of t, x and t is equal to fx of x and t plus c. So now these two should be equal for absolutely any value of c if this has to be strict sense stationary. So let's consider the value of c to be minus t. So if the value of c is minus t, we're going to get x comma 0. So it's easy to see that the PDF is not dependent on the value of t and is just dependent on the value of c. That's why the expected value will, so we know the formula for expected value is x into the PDF. So it'll be x into fx of x, which will basically leave you with a constant because you're integrating it with respect to x. So this will leave you with a constant. Now we will check what we get if we have the second order for SSS. So second order will basically be fx, x1, x2, t1, t2 should be equal to fx dash, x1, x2, t1 plus c, t2 plus c for any value of c. Now let's consider the value of c to be either t1 or t2, minus t1 or minus t2. So if we consider c to be minus t1, this value becomes 0, and here you get t2 minus t1. And if you consider c to be minus t2, this value becomes 0, and here you get t1 minus t2. So basically you're seeing that fx is a function of x1, x2, and the difference of t1 and t2, two time values. Therefore, it is easy to see that the correlation, which is basically the integration with respect to x1, x2 of fx of x1, x2, t1, t2 will be a function of t1 minus t2. So that's what we know for the second order strict sense stationary. Next, we go to the wide sense stationary process, which is the first part of the question. Wide sense stationary process is basically whatever consequences we see for the first order SSS and second order SSS are compulsory conditions for a process to be wide sense stationary. That is, the expected value should be a constant, and the autocorrelation function should be dependent on t1 minus t2 absolute value. So basically a process which satisfies these two conditions is a wide sense stationary process. So therefore it is easy to see that any strict sense stationary process can be a wide sense stationary process, but the inverse is not true. Not all wide sense stationary processes are strict sense stationary processes. And other than that, we have one exception, that if x of t is Gaussian, then wide sense stationary and strict sense stationary imply each other. Now next we go to independent increment processes. So independent increment processes is basically such that if you have two time intervals and they don't overlap each other, and we're considering a Poisson process here. So if you have two time intervals which do not overlap each other, then the PMF or even the expected value is independent of each other, and they are independent from each other. So consider 0t and 2t. These two are independent. So these two will have the same number of variables in the two non-overlapping intervals. So if we just try to note down the property, so for any Poisson process x of t, if you have two intervals t1, t2, and t3, t4, then we have x of t1, t2 minus t1 is independent of x of t3 minus t4 as long as t4 is greater than or equal to t3, which is greater than or equal to t2, which is greater than or equal to t1, and these are ordered and they don't overlap each other. So the joint PMF of the first interval x1 will be x of t2 minus t1, and the second interval will be x of t4 minus t3, and they will have the same PMF in this case. So the joint PMF of x1 x2 x1 x2 will be p of x1 and p of x2, and we're able to split these because they're non-overlapping and therefore they're independent. So that's what the property of independent increment process is. Next we go to the Markov process. So what we know of the Markov process is that if you have a process that looks like this, tn minus 1 up to t4, t3, t2, t1, so we can see tn is the smallest and tn is the largest value of time. So considering t1 greater than t2 greater than t3 greater than t4 up till tn, a general condition would be that probability of x of t less than or equal to x1 will be conditioned on everything that happened before it. So the probability of this happening will be conditioned on everything that happened before it. What the Markov property states is that the probability of this happening will only be conditioned on this. So basically, we say that the probability of anything happening in a Markov process is only conditioned on its second order statistics. So it's easy to see that probability of x of t1 less than or equal to x1 given x of t is equal to x of 2 is equal to x2. So we can also say that the nth order statistics can be known by the second order statistics. So how? So say suppose you know the second order statistics, so you can therefore find the first order statistics, and now you know the first and second order statistics. That's why it's easy to find t3, or even something after t1 could be found because now you've already found what happened at t1. So something that happened at t0 or up till tmth can be found just by knowing t2. Now going to the white noise, which is the last part of this question. So the property for white noise is basically, if white noise is denoted by n of t, then two processes happening at two different intervals of time are uncorrelated. So n of t1 and n of t2 are uncorrelated. Therefore, we can write that the expected value of n of t1 minus eta t1 into n of t2 minus eta t2 is equal to 0, uncorrelated. So by the end of it, we get Cn of t1 t2, which is the covariance, is q t1 into q t1 minus t2. So, but the basic property of white noise is that white noise happening at any two different intervals is always going to be uncorrelated to each other. Thank you.